Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be talking about channel design modifications, the newer method. So if you're in HEC RAS, I'll show you exactly what I'm going to talk about in this lesson right now, so you see what this video is about. If you have a cross sections already set up in a river reach and you click on Tools, I'm going to be talking about this second option here, this channel design slash modifications. So this is the diagram. This is the interface that we're going to be dealing with in this lesson. I just pointed that out right away because there are a few other options like channel modification original, graphical cross-section edits. Obviously, you can edit the cross-sections manually. So just wanted to let you know, in this lesson, we're going to be talking about this channel design slash modification. This is a newer method, I believe, and this may be your preferred method for modifying the channel in HEC RAS. There's also a user's manual page on this topic. I will leave a link to this page in the description, forming channel design slash modifications. And the first part of it actually covers what I already covered in lesson 15. But if you scroll down to right here, channel design modification tool options, this is lesson 16 from here all the way down to the bottom of the page. All right. Let's go ahead and get started. First, I want to show you what I have already in my model. Pretty simple, one river, one reach, and then three cross sections located at river station 0, 1,000, and 2,000 feet up from the base of the river station. All right, here is the cross section data in case you're curious. Right here is the cross section at station 0, 1,000, and 2,000. All right, so I'm going to go ahead and then come up to Tools, again, Channel Design Modification. All right, so what we have in this interface is a few things. The general concept behind the Channel Design Modification tool is that a user will develop cross-section templates, and then these templates will then be applied to existing cross-section data. So down in the bottom, I have my three cross sections, all River A, Reach 1, one row per cross section. And then I have this column over here for template, which I will apply a template, which I will create. The template will then be applied to existing cross-section data to perform channel modifications or to create new cross-sections on the river reach. In this interface here, the top half is more of visualization, and then the bottom half is more data input. So as data is being inputted and changed and so on, the visualization in the top half should be updating. Another important aspect button here is this one at the bottom, create a geometry file with these modifications. So right now we just have one geometry file, lesson 16. It's my .g01 file. But using this interface, I can create additional geometry files, which we could then link to new plan files and then run new simulations and look at the results to see how changes in the channel geometry would affect our results for water surface elevation and so on. Down here in the bottom half, we have alternatives. So right now it's starting me off with alternative 1 as a default. I can create new alternatives, rename, delete, and copy. So whichever alternative is selected here, then the action associated with that button will take action on that alternative. If I'm like renaming, deleting, or copying, for instance, I can create a new alternative, give it a name, but let's just stick with alternative 1 for now. These options here to create new, rename, and delete, they are the same options up here in the options menu, new alternative, rename, delete, and copy. Also, when saving data, if I make a change here, the unsaved numbers would appear in red text. And if it's in black text, like you're seeing here, that means the data is saved. We'll see an example of that a little bit later. And then also, if you're changing alternatives, that will automatically save the data in the previous alternative. Okay, let's go ahead and talk about this table from left to right. We have the river, we have the reach, we have the river station, and then the invert elevation of that cross section. So each row in this table is a cross section. Then we have the template elevation. This is the elevation at which the cross section template will be applied. Not directly editable, but it is based on the fixed elevation column right over here, and then the slope from upstream and slope from downstream. The default template elevation is the invert elevation. Then we have the left overbank channel and right overbank length. So that's pretty straightforward. Looking at the diagram here, we have a 1,000 feet length That's where the 1,000 are coming from. And then the station center is just 500 because the cross section for all three of these cross section is 1,000 feet across. Then we have a column for template. I mentioned this earlier. We're going to create a template and then we're going to assign it to make changes or modifications to any of these cross sections that we want. So more on that later. We have the fixed elevation slope from upstream and downstream. The template elevation is computed using the slope projected from the upstream and downstream cross sections and also the length from the upstream and downstream cross sections. The interpolated distance right here, this is the max distance for interpolation. The maximum interpolation distance between the current cross section and the next cross section downstream. If you leave this value blank, that just means that no interpolation is desired. And then the last two columns is cut and fill area, and that's in square feet. We'll see these columns calculated in action a little bit later. All right, let's get started with the template design. So the process here is creating a template and then applying it to a cross section to modify that cross section. We'll come up here to editing tools, create our templates here, and then in this button is when we'll apply the templates, or one way to do that. So if I click on template design, we have a whole new interface here, a new dialog box. We can also access this dialog box by going up to edit, template design, editor, and boom, here we are. All right, we don't have any templates yet. So to create a template, we'll just click on this new template button. I'll call it template 1. Okay. And then now I can rename, delete, and copy. So these are the same controls we saw with the alternative, as well as other places within HEC RAS. There's two different types of templates. There's simple trapezoid, which is the default it looks like. And then there's also user entered table. The cross-section template design editor here is used to create cross-section templates to modify existing cross-sections. So what I'm going to do is I'll do an example of both user entered table first and then simple trapezoid. So let's go ahead and type in some numbers here. Okay, so what I did here, this is working from the center of the cross section and moving in the left direction. And then this table over here to the right is starting at the center of the cross section and moving in the right direction. There's also this convenient button for copy left to right in case it's symmetrical. And I think in this case, I'll make it symmetrical just to save some time. So I'm always going to start off at 0, 0. You can either type in the dy and the dx and the slope will be calculated, or you can type in the dx and the slope, or the dy and the slope, and it should all calculate. For n values, I'm just going to keep it at a constant 0.05. All right, so this is not cumulative, this is incremental. So what I would do is from this location, I'll say 50 feet across and stay at 0, and then up 25 feet, so that'd be a 2-to-1 slope. Oh, I'm sorry, I went over 100 feet, so that was a 4-to-1 slope, excuse me. And then let's go up, let's go over 80, keep that flat. And then finally, let's go over another 100 and up another 25. So what we have is the left half of our cross section right here. I'm going to also put a radio button checkbox right here to represent the top of the main channel, the bank station. And then click this button, copy to right. The value is copied over, the display updated. And this is how I would specify a user entered table. So it's got more control. Also, there's this cut to daylight slope. Right now it's 0, which means it's just vertical. But if I maybe made it 4-to-1 like that, it would continue in the same slope as that last cross section. So that would be my template 1. I'm going to go ahead and just create a template 2. Boom. All right, so with template 2, I still have my template 1 saved right here. That didn't go anywhere. Template 2, I have the option for user entered table or simple trapezoid. This time I'm going to go with simple trapezoid and just kind of show you the difference. For channel depth, I'm going to say 25. Bottom width, I'm going to say 100 feet. I think this is in feet. Okay, side slope, I'll say 4 again, and then Manning's will be 0.05. All right, so I have the trapezoid. I believe this is about the same trapezoid as last time, but just a different way to do it. I'll say 4-to-1 on the side slope. Also, this fill channel below template, if checked, the option will fill the main channel of the cross section prior to applying the template. Or actually, let's leave that checked. I like that. And then, yeah, we'll keep the cut to daylight slope at 4-to-1. So that's 4 horizontal for 1 vertical, and looks good. And click OK. All right, we have two different templates to choose from, template 1 and template 2. I'm going to select template 2. You can go ahead and select template 2 right here in the table, but what I meant to do is click on this modify range of cross sections. So I'm only going to modify the cross section at River Station 2000. All right, so if I apply template 2 here, you see we have a fill area of 2,100 square feet. That's one way to do it. Another way to do it is to use this modify range at cross sections. So with cross section at River Station 2000, feet selected, I'm going to click on arrange. So that's 2000 here because I have 2000 selected when I clicked it. Let me just close that. If I selected 1000 and then modify arrange to cross section, it starts me off at 1000. Okay. So I'm going to go with 2000, but it doesn't really matter because I can change it right here. All right. So now what I want to do is apply the template 1 or template 2, or I could create a new template. This button right here will take me directly to the same template design editor right here if I wanted to create a new template, but I don't need to. I've already done that. We're going to apply template 2 to the cross section at River Station 2000 and also River Station 1000. All right. So when we make these selections, it provides me the invert elevation. But if I wanted to change that, I could specify the downstream slope or the upstream slope, or I should say slope from the upstream cross section. So if I put a value here, I think 0.02 is the current slope, and then it would do the calculation, and I think the answer would still be 32. So it's either one or the other. I'm just going to keep it at these elevations for now. And then also these values here for 1000 and 1000, it knew the distance automatically based on the table data. So that's all correct. Let's go ahead and click apply and see what happens. So I click apply. Now in the table, let me close this. We have template 2 and template 2 that are assigned to these two cross sections. So let me go view full plot. What I'm looking at here is the cross section at River Station 2000, and then this is at River Station 1000. So 2000, 1000 looks exactly the same. And then here is the cross section at River Station 0. No change because there's no template applied. So we have the cut area of 2,100 feet in both cases. That makes sense. If I click on this bulldozer button, it gives me a cut fill summary table. So if I do that, what I'm seeing is we have a net fill. Is that right? Let me go up to River Station 2000. Yes, fill, because this magenta line is the proposed slope, the proposed new channel change. So originally we had like 200 feet of base in our trapezoid, and our proposed only has 100 feet width of base in the main channel. And it looks like we have a little bit less steep slope on the sides. So that's where we're getting that fill value from. So I click on the bulldozer again, and in this box here we have all sorts of controls. We're seeing the volume here of 77,000, and that's in cubic yard, I believe, because the volume up here says cubic yard. We can toggle off some of these columns if we want, and then we can also look at the area by toggling on these checkboxes. So we have more data to report if you wanted to see a report like this. Now we're seeing twice as much volume coming from cross section at River Station 2000 to 1000 compared to 1000 down to River Station 0. And that's just because it's, a rectangle compared to a triangle. The volume pinches out at River Station 0 because there's no modifications applied to this downstream most cross section. Okay, so that makes sense. I'm just going to close that. Next, what I want to do is click on this button to create a geometry file with these modifications. Okay, so it's telling me I need to save the original geometry file, so say yes to this. And then what I'm going to do here is call this lesson 16 modification 1. So this is going to save a geometry file .g02, I believe. So I'll click OK. Okay, I think I already had a file saved. That's all right. And now what I have is my .g02 here. And then my modification 1 is the title for the current geometry file. Let's go ahead and take a look at that. And here's the cross-section data. So that looks good. Here's the original cross-section at River Station 0. If I go upstream, we see the change has been made because it's only 100 feet across here. It should look the same here. And yes, at River Station 2000, here is the modified cross-section. Okay, let's go back and make a few more modifications and create a few more geometry files. So I'll go to Tools, Channel Design Modification. So we're starting off where we were on the most recent geometry file. Let's go ahead and apply that same template to the cross section at river station 0. So go modify. I'll change this to 0 and 0 and template 2. Okay, I think that's good. I'll click apply and close. So now we're making that same change right here. I'm going to accept the changes and just click on save. Again, it's asking me if I want to save it. I do. And then I'll call this mod2 for a file called .g03 and then click OK. Okay. The next modification I want to make is to the channel slope. So if I go to tools, channel design / modification, the whole time we've been looking at this XS plot tab, the cross section, but we can also click on profile plot. And this is the profile of our river. So it flows downstream at, I believe, 0.2%. So fairly flat. What I want to do here as just an example is change this slope from river station 1000 to 2000 to half of what it is here. So this is 0.2%. This is going to be 0.1%, and that would invoke some cut in the cut fill calculations. So to do that, we would select modify range of cross section. I'm going to use the same template, so that's not going to change anything. But what I'm going to do here is select 1000 to 2000. And then instead of 34, it's actually going to be 33, but I'm going to specify it using the slope. So I'll say 0.001 and then tab off of that. And then everything else is good here. So I'll click apply and then close. And now what I see in the magenta line here is the cut invert. Like this is the proposed invert of the channel after this change has been made. And you see we have some data here. 32 is the fixed elevation, and then the slope is 0.001. And we have 384 square feet of cut, and we can also get the volume calculations at just over 7,000 cubic yards. Okay, so I'm going to go ahead and make that change and then save that as modification 3. So this will overall be our 4th geometry file. Okay. Okay. And then let's go ahead and check that out. So this one is loaded. I think I can go plot and then plot profile. And sure enough, that change has been updated. So we see the 0.1% and then 0.2% channel slope. So far, this example is fairly straightforward. In all my exercises and lessons, I try to make fairly simple lessons because we're all learning together. This is a beginner lesson. But I should mention that the user manual does have some more in-depth examples here. So what you're seeing here is a cross section with 30 or 40 different points, and then there's like 10 or 12 different cross sections you're seeing in this interface. So you can just kind of get an idea of the level of detail and how helpful some of these tools are, especially as you get more points in your cross section and then more cross sections in your river reach. Next, I want to demonstrate how to add a new cross section using this interface, the channel design / modification. I'm going to create a new cross section at river station 500. So that would basically be halfway between 0 and 1000 in my river reach. And that's this button right here, I believe. Yeah, add new design cross section. So I click that button here. I'll give it a river station of 500. Make sure you have the river and reach selected. I'll click OK. It added a row here to my table here. So for river station 500, that's correct. What I need to do is update the reach lengths, and then it should update the invert elevation using linear interpolation. So no longer is one river station cross section 1,000 feet down upstream of the next downstream cross section. I need to change this, and I'll change it to 500. Boom. Okay. Now there's a quick way to make edits here instead of just typing using some of the tools up here. So for instance, this is to add a value to an existing value, multiply a value by an existing value. This would be find and replace. This is rename. No, this is find and replace. This one here is just set. So if I wanted to set all 3 of these to 500, I could just come here and say, oh, 500. Okay. Just the selected area. Okay. And then boom. Now in this simple example, typing it would probably have been just as fast, but I want to let you know you can highlight certain values in this table and use these tools to do group edits, batch edits. All right. So I also want these 3 to also be 500. I could add 500 to what it is, 0, and see if that works. 0 cells modified. Not sure why that's the case. Okay, let me go ahead and just try setting it 500. Okay, so that worked. And just like that, the invert elevation of 31 is calculated. So that's exactly what I wanted. Okay, I'm going to go ahead and save this as my next geometry file. This is modification 4. Okay, and mod 4. Okay. And if I click on cross section over here, I should now have river station 0, 500, 1000, and 2000. If I click on the plot and then see the profile, this is what I was expecting to see here. So we just added the river station cross section here at 500, and it's in line and on the same slope as the segment from 0 to 1000. All right. Well, that was it for this lesson. We talked about the different ways to change the channel design or modification from the geometric data editor, tools, channel design and modification. We created a couple different templates, a couple different ways, and then applied one of the templates to our cross section, calculated some of the cut fill data, and then also added a cross section and changed the channel slope. So that's a lot of different ways you can modify the channel design in HEC RAS.